All right, welcome. We are starting a new unit, and the unit deals with dilation, scale factor, and similarity as the concepts. So I'm going to give you a quick example. Okay, so let's say, for example, that I have the border of a country right here. It looks, I don't know, kind of like a Pac-Man a little bit. Okay, so I've got that, and let's just say the distance from here to here is, let's say, the um, 3 inches. And then all of a sudden I take this, I copy it, control copy, and then I make another one. Right now it's the exact same size, right? So this side would still be the same. These are also similar. They're also congruent, really. Like in the last chapter, we learned about congruency. So all the sides will be the same from here to here. It should be 3. What if I take this and I enlarge it proportionally? And let's say I do it 3 times. I don't know if that's exactly 3, but the point is it's bigger. And let's say it's 3 times bigger. So now instead of this being 3 inches, it's going to be 3 times 3 inches or 9 inches. Okay. I don't know if you've ever seen like maps where you see like a map of the United States and it tells you what the scale is. So you can figure out using the map based upon the distance on a map, what you would multiply it by to get what the actual distance is. This is called the scaling factor, right? Scale factor. But the shape of the map of the United States should look exactly what the United States actually looks like in reality. But to figure out distances, corresponding distances, you would need to multiply by some scale factor. Or if you wanted to go back the reverse way, you could say, well, in the United States, this particular distance is 9 inches, but what would it be on the map that we have? Well, we'd have to divide by the scale factor, okay? All right, so that's what we're learning about today is things that have the same shape but different sizes. So if we go to page 1 of the notes, similar figures have corresponding angles. So that means the angles correspond and they are congruent, and corresponding sides that are proportional. And we'll talk about that in a minute. I'm going to change my color here to a more normal color for this. Okay, so what does that mean? Okay, so let's take 2 triangles here. We've got a new symbol, by the way, right here. This squiggly line. You notice it's not that. It's just a squiggly line. What that says is that it's similar, meaning it has the same shape. So if you look at this triangle here, DOG, and this one here, CAT, or dog and cat, they have the same shape, although this one looks like it's been rotated, right? But they have a different size. So the thing that you're trying to do is now you're trying to match up the angles first, and then the side ratio. So how do we match up the angles? Well, we did that before in order. When they write it like this, order matters, meaning the first letter is D. So that corresponds to the first letter over here, which is going to be angle C. Okay. Then the next one is going to be O, which corresponds to A. And then G to T. Again, it's just about going in the same order. When you write it out, by the way, you're going to have to remember that. Now, what does the side ratio mean? It means that the length of DO, whatever that is, and that's, by the way, what that means is DO, right? Should be a line over it like that. That's going to correspond to a side over here. How do we figure that out? Well, again, we can use the order over here. So DO are the first 2 letters, and CA are the first 2 letters. So that means DO goes with CA, and okay. And then what's the other side? Then we have OG. Why don't we do OG? So OG's is going to be the second and the third. So AT would go with that. Second and the third. Okay. And then finally, the last one is going to be what? DG. Corresponds to the last one here, TC. Okay. So that's the statement. I think it's actually a lot easier to understand this when you have the numbers so you can see why the ratios remain the same. But we're going to see that here in just a moment. Okay, so anyway, that's the first part about that. Okay, the next thing is writing similarity statements for the triangle. So what I'd like you to do is is try it out. Pause me for a little bit. Look at what I did right there. And here, though, instead of getting the statement, we've got two triangles. We're going to try to think about what it would be. So take a moment to pause me and think if you can do that, and then I'll go over it. Okay, so the similarity statement. So here they're telling us these are similarity, right? Right here with the symbol. So we already know they're similar. That means they're going to have the same angles. Well, 51 and 39 can't be the same, right? Obviously. But we know 90 is the same, which means the third one missing has to be the same. Now you can do the math and say 51 plus 90 and then subtract that from 180. But if they're similar, you know that one of these has got to be 39 and it can't be 51 or that. So clearly this has got to be the 39 and vice versa. This has got to be your 51. Okay. So the next thing is when we write out the statements, we got to make sure that it's in the same order. So let's just, you can write anything for the first one, A, B, C. But when you do the second one, it's got to be in the same order. So A is the right triangle, right? A right angle. So I'm going to make sure that that's M. That's the right angle. B is a 51. So L is the 51. And then we have N. So it's got to be the same angles. They've got to be in the same places. Okay, over here, you might say, well, we don't have any angles, but the sides are proportionate. So that's where this comes into play. You can try this if you want to try to think about what it would be. But I'm going to give you a hint. If you're not sure, you got to match up sides. So I look right at this and I say, well, the biggest side over here is 18. So clearly that's got to match. If these are similar, that's got to match the biggest side over there, right? Smallest is 10, so that's got to match the smallest, which is 15. So there you go. There's your clue. So you can match up sides to sides. What does that tell me? If I start with the biggest side, 18, and this is the biggest side, that tells me that that MN goes with FE. Okay, so let me just write, let me just write any, on the first triangle you can write anything, but so I'll go in alphabetical order, E, F, G. Now, EF, this is the way to do sides. With angles, you could just do one letter at a time. For example, A, you could say, well, that's the 90. So M, that's the 90, first one, right? Here with sides, it's better to go two letters, but you got to make sure the order's right. So EF, first two letters. So I'm going to, and then the second biggest side would be what? Let's say, so 21 is the second biggest. I'll underline the second biggest side, so that. So what I'm going to do is I'm going to start with the letter E, goes through the biggest side to F, and then goes down the second biggest side to G. So first the biggest side, second biggest side. So I'm going to start with what goes through the biggest side and the second biggest side. Okay, if I started with M, and it goes through the biggest side to N, and then goes to L. So EFG matches that. Now I can also try it like this. EG is the smallest side, right? So these two here are the smallest side. So ML should be the smallest. ML is the smallest, which it is, 15. Okay, so that's how you can match up the sides. Okay, one last thing. What is the scale factor of two similar figures? It's the ratio of the image to the pre-image. We're going to talk about that in a moment, but basically what would the scale factor be between these two here? Well, you can take any two corresponding sides, but make sure it's either you're taking the two smallest or the two biggest. So for example, if I want to say, what do I multiply all the sides in EFG to get over here? That would be the scale factor. What do I multiply all the sides by to get all the sides over here? So what I can do is I can take this 27, the biggest, divided by the biggest over here, which is 18, and get the scale factor. So I go 27 divided by 18 equals 1.5. Okay, so what does that tell me? It tells me that I can take 18 and multiply it by 1.5 to get 27, and then I'd have to do it to all the other sides. So let's see, for example, 10, if I multiply that by 1.5, that would get me 15, which is the smallest one on the other side. So if I know the scale factor is 1.5, I can multiply by all these sides to get the bigger triangle sides, or I can go in reverse. Let's just say I'm trying to figure out the smaller side. If I know the scale factor is 1.5 and I'm taking the biggest side and I want to figure out the biggest side for the smaller one, I could go 27 divided by 1.5 and that would get me my 18. Okay, so that's what your scale factor does. An enlargement occurs when the pre-image, well, I should say when the image, the secondary figure, is larger than the pre-image. Let's just say this is a pre-image, the first figure, and then this is the image after the change. That would be an enlargement. Or if we started with the bigger one and went to the smaller one, that would be a reduction. Okay, so today that's good enough for your notes to be able to do the assignment for today. So make sure you've got these notes and make sure to show me when you're done so I can give you credit for taking notes. And then what we're going to do is we're going to look at the assignment. So the assignment that I passed out has got, let me go ahead and look over here. One sec. Okay, for the assignment today, these are not notes, but I'm going to go over the first two question types on the assignment. First, you're given that two triangles are similar, and you're going to try to find the missing length. And then the second one is you're going to basically do the same thing, but now you're going to solve for x to try to find that side. So the first one, what do we do on the first one? Okay, on the first one, they give you the similarity statement. So you know that the order is something you can go by. So what I'm going to do is I see that there's only one side over here, but the other one's got two sides. So I want to find two corresponding sides so I can figure out the scale factor. Once I figure out the scale factor, I can just take the other side and let me just go ahead and show you. Hopefully that'll make sense. So, okay, I know I have VW, so it's the only side I have on this one over here. So I'm going to see if I can match that up to the side over here. So VW, second letter and third, so that'd be GH. GH is this one. Okay, so good. So that means that the 26 goes with the 143. So I'd like to put the bigger side over from the bigger triangle over the smaller side. But these are corresponding sides, okay? So over 26. So that should equal another side. Now we've also got to use the 66, right? So remember this. I always tell students put B for bigger over S for smaller equals, and then the sides that you get. And if you want, you can put FG over here, and you can put VW here. But now we need to match it up with the other side that we have, so we can figure out this. So FV goes with what? FV goes with the first two letters, right? So now we need to match that up with the first two letters on the triangle below. First two letters. Good, FG. So that means the big is on the top divided by the question mark. I'm going to put X. It just seems more standard. So now that we've got that, now we can solve for that X. Okay, so here you got to remember cross multiplication. Whenever you've got an X and you got one fraction equaling the other, you can cross multiply, meaning you can take X times 143 equals that. So 143X equals 66 times 26. Then you can multiply it out. Where to go? 1716. And then divide by 143. So where do you go? Divide by 12. Okay, so X equals 12. Okay, so that would be the answer. Now, maybe a quicker way to do it, there's two ways to do cross multiplication. I can take 143 over here and divide by 26 to see the scale factor. Okay, so I took 143 divided by 26, I got 5.5. And so then I can take 6.6. Now you might say, well, are you going to multiply it by 5.5 or divide? Well, for one thing, you know that you're getting a smaller triangle on the bottom, so you'd have to divide. So if I took 66 and divided by 5.5, I would get 12. Okay, so that's how you do that kind of problem. Really quickly on the second one, I'm going to go quicker on this one because I'm going to run out of time in about 40 seconds, but I'll show you the setup. Okay, I'm going to go kind of quick on this because I've got 30 seconds to go. But basically, this is what I did. When you got triangles overlapping like this, it means all the corresponding sides, like this side right here is going to go with the bigger side out like that. It's almost like this thing has been increased that way. This bottom part here is going to correspond to that part right there, and this 50 is going to correspond to the larger one. Now, when you got a line like that, it says from here to here is 120. Well, if this part's 50, then this part would be 70. Anyway, what I did is I took two sides that I've got, divided it by 55. Anyway, look at this.